Okay, so the next question is next greater element 3. So let's give the question a read. Given a positive integer n, find the smallest integer which has exactly the same digit existing in integer n and is greater in value from value than n. If no such positive integer exists, return -1. Okay, so basically what I am understanding is that we will be given with an integer n and we need to make another integer which is having the same digits existing in the given integer, but the value should be, the corresponding value should be greater than the given n, and it should be exactly the next greater one, right? So if I take a better example, there are no good examples over here. If I take a good example, guys, if I take a good example, for example, the n that is given to us is 1 and then a 4, for example, and then suppose 6 and then 5, then a 4, then a 3. This is the example that I want to take. Let us also take a smaller example. Suppose 5, 6, 8, 3, 2. Suppose this is another example. Okay. So now guys, if I try to manually find out which one is the next immediate greater element that can be, next greater integer that can be formed using this exact same digits, if I try to find one, see over here, if I try to make, so obviously I cannot make 34, 34 will be smaller. 543, obviously this 543 is maxed out. 5543, this is also maxed out, guys. I cannot change this like with this integers, I cannot form a greater number. This is already maxed out. This is also maxed out. Over here when I come, I can see that okay, there is a scope because it is 1, 4 and then certain numbers. I can replace this with a 5 and I can maybe form a greater number, right? So 1, and if I replace this with a 5, then I should make it as minimum as possible. So all the rest of the digits are which are present. 1 is over here, 1 is constant, 5 is also replaced. Now the rest of the digits should be as it is. I am manually trying to do, guys, in pen and paper. Okay. So obviously rest of the digits should be sorted. So basically 5 is there, so 3 is there, 2 4s are there, 2 5s are there. Sorry, 1 5 I have already used. So only 1 5 is there and the last one is 6 which is remaining. So this is the next greater element. Using these digits you cannot find a greater one. You cannot find a number which is in between these two, right? So this will be our output. Now similar thing over here, see 32 is over here, I cannot make it 23, it will be smaller than it. Then there is 832, so already it is again maxed. Now 6832, okay, this is not maxed, I can make a bigger number because 8 is over here, right? So obviously 5 will be there, 8000, and then once I have already increased this 6 cannot be replaced with 3 or 2 because that will be smaller. 8 is there, I am writing 8. After that I should sort all the rest of the digits, so 2, 3 and 6. So you need to, this is the way, like from here till here, how you are getting, you have to logically find things out. Okay, I have already tried to say you how we are finding things, but before going more deep into there, so basically whatever n is given to us, we need to create another number which is formed of the same number, same digits, but is greater than it, immediately greater. So this is what we want. And another thing is, these digits are not there in a array form, like these are not an array, this is a complete integer. We need to break and work on it. Okay, that is another thing. And we are missing out on this line, if no such positive integer exists, return -1. Maybe the n that is given to us is suppose 86532. okay, I am only using these digits only, the second example. So if this number is given to us as input, can you make a number which is greater than this? No, it is not possible. Here is also an observation. When can you find this? See, all the digits are kind of sorted from last, right? It is in increasing order from the last. So if such a case exists, we should return -1 because no, with these digits we cannot form a greater number. That's the thing. So guys, over here we can see that this part is, let me take another example. Over here you can see that this part has not changed, this part has not changed. If I take another example, suppose 567, Okay, the next immediately greater number will be 576. Here also this thing did not change. So what is special in this digit over here, this 6 over here and this 6 over here, that before it all the numbers are unchanged. If I also make a greater number, if I just change this 2 and 3 now is 5, 6, 8, 2, 3. If this is the input that is given to us, the output will be what? 5, 6, 8, 3, 2. So in this case all these things are fixed. Something is special about this 2, where due to which from this point or from this point or from this point the numbers are changing. What is the special thing? Try to pause and think about this for 10 minutes. You will be able to figure out the whole solution. That is the thing that you should do. I hope you have done it. Let's continue. The unique thing about this is, guys, if we travel from back, all these are in increasing order. See, 3, then 4, then 5. That's why these all were maxed out. So that's why I cannot change only this portion and make a greater number. This was already maxed out. We have already learned the logic for maxed out. Everything will be in increasing order. So everything until this point over here was in increasing order. That is why this point was special, because this 4 over here is smaller than the next one. Any other number over here after this, we are traveling from back, so after this there is no such integer which is smaller than its, which is smaller than its next integer, next digit, right? Over here also see 2, then 3, then it is increasing. Here there is a decrease. Over here see, from 3 to 2 only there is a decrease. So this point was finalized. So the first point it is clear. The first step is travel from back or iterate from back, and stop when you find a digit which is smaller than the next digit. Okay, that is our point from which the things will change. Before that particular point everything is fixed. Now after that you can see this 4 is not staying 4, this has changed. This 4 over here has changed to 5 in the output. This 6 has changed to 8. This 2 over here has changed to 3, right? So you can see that portion, the position where the decreased number was found, that position was replaced by a number, by a different digit which is greater than it. Or after this particular digit, from all other digits 5 was the immediate greater digit. It was replaced with the immediate greater digit. 6 was replaced with the immediate greater digit. Well, in this case there was only one digit that is greater. Here also there is only one digit which is greater. But if there are multiple, in this case, first case over here, from 4, 5 is also greater, 6 is also greater. But I have taken 5 and not 6 because immediate greater is 5. So we are replacing this targeted this particular position with the next greater digit. So replace that particular position with the immediate greater digit, right? After that, once we replace this, then the next part is sorted. See, the next parts are sorted. The next part is sorted, right? So we should sort the remaining of the integers. So from index 0 to our target to target index, everything is fixed, everything remains same, for rest of the digits we should sort them. We should sort the rest of the digits from the fixed part. After we find out where was the decreasing element and then replace it, this part becomes fixed part. This part is the fixed part. After replacing, this part over here is fixed and the remaining portion should be sorted. Now let us try with a fresh number. We are not coding it up, guys. We are just developing the logic, how we can in pen and paper, if a number is given to us, how we can get the next greater number. So basically if we are given with a big number 1, 2, suppose this is the number that is given to us, what you should do? Travel from the back and try to find out where the number is getting decreased. Okay, suppose this is the number. So travel from back, this is increasing, this is also increasing, this is decreasing. So this is our target position. So this part over here will be, so next part I have identified the target position. Now I should replace this 5 with a greater number that is present to the right of it. So obviously 8 is also greater, 6 is also greater, but what is immediate greater? 6. So I should replace this with 6. So 1 5 4 6. Now this becomes my fixed part. Now once I have these digits, what are the digits that are remaining? I have a 5 left, a 4 left, a 6 left and a 8 left, right? So I should sort all this 4 5 6 8, 4 5 6 8. So this is my output. I hope it is clear how the logic is working. Now let us talk a little bit about, like this is a very good point where you can start coding it on your own. Okay, so these 3 steps can be these 3 steps can be followed in multiple ways, but I'll show you one of the main ways how we can do it in an optimized way. But let us talk about how we can implement this using code. I hope you have already paused and tried it from your end, but okay, if you are not able to figure it out, let's continue, or just verify if you have done it the correct way. See, programmatically what we can do is, guys, it is not a new concept that obviously if I need to store what are the digits we have, we can use a hash map. We can use a hash map, that is pretty clear, right? But obviously guys, if we need to keep track of only digits, then why to create a hash map for it? I don't need a hash map for it. I can create an array of size 10. We can create an array of size 10 and say that how many 4s are there, I will be using this cell, this index 4 will store how many 4s are there. Then 1 6 is there, so 6 will be stored. Then 8 is there. I am traveling backwards in this particular output, in this particular input. See, after that a 5 is there, so I will take 5. Then a 4 is there, for example, so I will increment this. I can use this, right? This is not a new concept. If we are trying to keep track of characters, instead of creating a hash map, what you can do is we can create an array of size 26, where in index 0 we will be keeping the count of the number of A's. In index 25 we will be keeping the count of number of Z's. So this is a known concept, right? So we can utilize like while traveling backwards, we can keep which digit we have extracted out from the number, and we can keep a track of the number of digits that we have already seen, right? Now after doing that, we will be traveling backwards and we will be storing the digits that we have seen in my array, and also along with that we will be stopping as soon as we find a smaller element. As soon as we find a smaller element which is smaller than the next digit, we should stop then and there. And after that, whatever elements we have seen that is stored in this array, we should replace it with the next greater element that is present. That is the next part. And after that, in this array only, we can use this particular array only, we can iterate through this array, and whatever the digits were remaining, I can append that in a sorted fashion. Like I don't need to again invest on sorting, because if I travel one by one, suppose in any particular scenario, imagine that there are, suppose 0 1 2 3 4 5 6, there are more, suppose 2 2s are there, then 3 3s are there, then suppose 1 4 is there, then 3 5s are there. So I don't need to sort these digits, I can just iterate through this array. So there is 0 zeros, so suppose there is a fixed part over here, the fixed part of the number is over here, there are multiple digits. After that, the remaining integers I need to put it in a sorted fashion. So I can just iterate through this array, 0 number of 0, so I don't put a 0, then 0 number of 1s, I don't put a 1, then there are 2 2s, so I put 2 2s over here, then there are 3 3s, so I put 3 3s over here, then there is 1 4 and 3 5s, so 1 4 and 3 5s. So I can just iterate through this particular array and form the rest of the numbers in a sorted fashion without investing n log n time in sorting, right? So this is the way I can programmatically do it. So this is also a great time to go and code it up on your own. Otherwise, just stay with me, I will show you how the code is done. Before that, I think I have left this part, that note that the returned integer should fit in 32-bit integer if there is a valid answer, but if it does not fit in a 32-bit integer, return -1. So basically what it is saying is that maybe very large number is given to us as input, okay, a very large number is given to us as input, and using those combination of digit I can make a even greater number, but that will be out of range from integer. So in that case we have to return -1. That is a edge case that we need to take care of, nothing else, right? I hope you are able to understand when this situation might arise. If there is a very big number which is the last possible number, which is basically nothing but 2 to the power of 31 minus 1, if this number if you write down this number, then guys there can be a number which will be possible to be formed with those same digit, but that will be greater, and that will be greater than this number. But as soon as the number goes beyond this number, it will be outside the range of integers and we will not be able to accommodate it. So in that case also we need to return -1. This is just another edge case. This is like the logics are quite simple, but there are small logics. So again this will also be a long video, I guess. Cool. So what we need to do is, for calculating the digits that we have while traveling backwards, we need to keep track of the digits that we have taken. For that I have talked about that we should use an array. Suppose digits, let's keep this as digits equals to new int, and the size should be 10. There are 10 digits from 0 to 9. I need to keep track of the next digit in order to compare the previous digit, right? Suppose I am decreasing this number, suppose the number is present over here, okay, any number, let us take any number. We need to split this number. So basically we will be extracting the last digit using modulus 10, and then we will be dividing the number by 10 to decrease it. So this 587, it will be 587 after the first iteration, then 58, like that, right? So basically whenever I extract out this 3, then I should store it somewhere so that I can check if 7 was greater than it or smaller than it, then only I can figure out, right? So at a particular time I should store the last digit and also the second last digit, right? So I will make two variables for those. So int last digit and suppose second last, okay. These are the two variables that I am making. Now what I am saying is that this n, when I am forming a number, that can be a long number, so I am taking long num equals to n. Obviously this is a long value, can hold an integer value, no, nothing wrong in here. After that what I can do is, while I need to work on this num thing, I should work until this num is less than 0. Once after dividing everything, once it becomes 0, that is the point we should stop. After going in here, we should extract the last digit. So basically last digit value will be initialized with, suppose at the starting we are initializing these two variables with -1, because obviously no digit will be -1. -1 is a safe value to take because it is not a real value. All the values will be greater than this. This is not a real value of a remainder, right? This is not a valid digit, -1. So I can give anything, any minus sign also I could have given, or 10, 20, anything. Cool. So in last digit, guys, what will be the last digit? Num modulus 10 will be the last digit. If I divide the number by 10, then the remainder will be the last digit only. After that, what we do, after finding out the last digit, guys, I need to find out if this last digit was greater than the second last. Sorry, I've written this second last. If my second last digit is greater than the last digit, guys, I'm traveling from backward, so this will be my last digit and this will be my second last digit at this position. When the number is 1545, this is my last digit and this will be my second last digit. So when my last digit is smaller than the second last digit, when my last digit is smaller than second last, then what I should do is, that is the point I have captured. Now what I can do, okay, one more step is I am missing. So once I get this last digit, okay, I should also decrease the number here only. Num equals to num divide equals to 10, right? So I am dividing the number by 10, and also whatever digit I got, I should store that, I should keep account of that. So how should I do it? Suppose if it is a 5, I should increment the index 5 value to 1. In Java, from beginning by default the values are 0. If you are doing in some other coding language, initially this digits should contain all the values as 0, because initially the count of all the digits are 0. As soon as I saw 5, for example, if the last digit is 5, what I should do is digits of the index should be last digit. So index 5 should be incremented, right? This is what we should do. Then what I am saying, suppose if this condition does not match, then we will be going to the next particular digit, right? Suppose in this case I got 4 and then there is a 6, right? So I should keep on going over here. So if this condition does not match, what I should do is I should assign my second last as my last digit. So the last digit becomes the second last now, and in the next iteration we will get a new last digit. Okay, so but if we get this spot, guys, if we get this spot where the number is in decreasing fashion, then and there only I can pick out the greater number which is after it, greater digit which is after it, and then sort the remaining digits then and there only. As soon as we get this, as soon as this condition satisfied, this is very important, as soon as this condition satisfies, at that position only we will be getting an answer. So what are the steps to go reach to the answer? First I need to replace it. Once I have found the spot, the second step was to replace that with the next available digits, whatever, like we were traveling from the back, all the digits were stored in this digits array. Now I got a place where this particular thing is dipping, the second last is greater than the last digit. In that case, what I should do is, whatever was there in my second last, I should assign, I am taking a temporary variable and assigning that to second last. So this was the value that was present in the spot. I need to replace that with the with a value which is greater. So I should start a loop int I equals to second last. So I can use a while loop for this as well. I can also use a while loop. So what I am trying to do is, guys, suppose this is a 5 that I have encountered. 5 was the second last when I got it. So sorry, last digit, right? In term should be last digit, guys. Last digit. I am explaining this part. What I am saying is over here 8 was here, then we got a 5. As soon as we got a 5, this was last digit, this was last, and this was second last, right? So as soon as I got this 5 from the remaining sections, I should replace this with the next greater element. So if I dry run up till here, guys, what is there is, suppose I am making an array of size 10. So first 4 came, okay, 4 was and initially as I have given this as a value of -1, this condition will not be satisfied because second last is -1, which will be never greater. So in the first case nothing happens and we go out and this second last comes in. So we have this second last becomes this 4, and before that we have incremented the value of 4. As soon as we got a 4, we have incremented this to 1. Now after that we got a 6, the second last become 4 and the latest last digit becomes 6. Now this is not greater than this, so basically we continue. Now this second last becomes 6. Okay, 6 will be incremented over here in this array. After that 6 in the next iteration my last digit will be 8 and 6, again the condition does not matches, but 8 will be over here incremented. Now as soon as we get 5, the last digit with the second last will become 8, then my last digit in the next iteration it will become 5. As soon as I get a 5, my second last is greater than last, so the condition matches. As soon as the condition matches, this 5 should be replaced by what? 6. How can I get this 6? If I travel in this array, guys, after 5, if I travel to the rest of the remaining of the portion, whenever at first I get a number, I can take that. Maybe there is a possibility that 6 was 0 and 7 was 1. So if it is a 0, I should ignore. 6 was not present, I cannot take like replace the 5 with a 6 because 6 was not present, maybe a 7 was present, so I can take that 7. So that is what I am trying to implement over here now. So as soon as I got this condition, as soon as this condition matched that the second last was greater than the last digit, I am trying to search in the space of 1 plus the last digit. So from this position I need to search if this digit array is not empty, like if it is 0 I should like carry on. So if digits of temp is equals to 0, then I have not got a number to replace, I should like carry on. So I will just do temp plus plus, right. So I will be iterating through all the zeros. After, suppose I have found a 5, now the next greater is 8, so I should ignore 6, ignore 7, and as soon as 8, under 8 there is at least 1, if the value is at least 1, then like if it is not 0, then there is some value, valid value over there, there is at least one digit of that instance present, so I will stop. So my temp is now stopping at 8, it will move on, first it will be 6, it will become 7, then as soon as this become 8 is present once for example, then this particular condition will not match and my temp will stop at 8. Now I should like replace that 5 with 8, right. So as soon as I replace the 5 with a 8, the count of that 8 should decrease. So that is what I should do. I will in this digits array, of temp, I should decrement this value. I should decrement it by 1 because I am taking one instant of that variable. Now I have already divided my number by 10. What I am saying is until now what I have done, we came across a 4 was incremented over here, then we came across a 7 was also incremented, then we came across a 8 was also incremented. While doing this, the num was getting changed, right. Num first became 1 5 4 5 8 7, then it became 1 5 4 5 8, then it became 1 5 4 5, then after that when it became 1 5 4 5, in that iteration it went inside and the last value of last digit became 5. Last digit was 5 and second last at that point was 8, and then the condition matched that second last is greater than last, this condition matched. But by that time we had already divided the num by 10, see over here we have already divided by the num by 10. So the number had become 154, when this 5 was assigned to last digit the number was also reduced to 154. Now that is desirable only guys, I need to find out that okay this was the target place where the changes would have occurred, this is the target place we have found, we should also would have removed this because this should be replaced with the next greater. So how we are calculating the next greater was, guys, the while loop part, let us see. So while over here I took last digit was 5, last digit plus 1, so I started iterating from here this position, and what I wrote was while nums of temp is equals to 0, I should do temp plus plus. So initially temp was what? Temp was 6 because I assigned it with last digit plus 1. So temp was 6. So for 6 it is 0. So it came inside and it went to the next one to check if 7 is present because 6 was not present after like whatever digits we saw, 6 was not present. So it ignored that 6 and then it went to 7. So as soon as we get a 7, we should replace that, like over here after 154, 7 should come in. So if we utilize this 7, the value of this 7 should be decremented as well. So after this part what we did was we decremented the value of 7. So we did what? Digits, this was digits guys, digits. So digits of temp was decremented after this. After that whatever the number was remaining, num was the number, the variable name was num. With this num we should multiply 10 and add what? Add this temp. Temp was pointing to 7, right? 6 was crossed and temp plus plus, the value of temp becomes 7. So after this we should 154 and then it should be 7. So basically 154 was there, we multiplied it with 10, so it became 1540. After that we should add 7, 1547, that is what we should do. And after that the rest of the digits whatever is remaining we should place them. For placing that I have already shown, we can just iterate through this array, and how many instance of whatever digit was remaining we can just put them at the back. So let us come back to the code over here. If this condition match that second last is greater than the last, I am trying to find out in the digits array, I am trying to stop whenever the value is not equals to, when the value is not 0, we are stopping then and there, and that digit we are decrementing it, and with this num I should do num equals to num into 10 and add this temp, because temp is the immediate greater number of the target position. So num into 10 plus temp was done, and then this number was like 1547 is done. Now what I should do, I should iterate over the digits array, and whichever digit is having a valid value, I should go on placing that digit, append that digit at the end of our num. So I will iterate this whole digits array int I equals to 0, I less than 10, I plus plus. What I am doing is, while the value is, suppose in any place, I have shown you already over here, in any place I was forming this number, if there are 2 2's, then we will be placing 2 2's after this, then there are 3 3's, so we are placing 3 3's, then 1 4, we are placing 1 4. So until and unless any value becomes 0, we should keep placing that particular value. So while my digits of I is not equals to 0, until and unless it becomes 0, I should add that particular digit, num equals to num into 10, appending a number to the end, we multiply it with 10 and then append the digit, plus digits of I, plus I only, right, the digit that is present is I only, I should add one more I and then decrement the count of that particular digit. So digits of I should be decremented, right, after every addition, and we will be doing it until the last one, and finally this num will be prepared. So once this condition is matched, we get our target position, then we do all this, we replace the value, this is the portion where we replace the value with the next greater number, this is the value, this is the part where we reach the next greater number, we decrease its count, and then we put it with our number, append it with our number, then rest of the numbers we fill one by one in the sorted form. After that our number is formed. Now there is a possibility, remember guys, that there is a possibility that the number formed can be greater than 32 bit. So in that case we need to return -1. So after the number is formed, we need to perform a check that if my num, which is a long variable, if it is greater than integer dot max value, then I should return -1. Otherwise, else we have already made the number, we should return the number as it is, return num, correct. And obviously if this condition does not match, we come outside and assign the second last with last digit that was formed, and in the next iteration we will be getting a new last digit. And if all this is completed and still we have not returned anything, then that means guys that we have this particular, if this particular condition matches, then we will be for sure returning something. In this if else, either one of this return statement will execute. But if this condition only does not match once, that is the number that was given, it was already in sorted digit fashion, like it was in decreasing fashion, and when we look from the last it was in increasing order, then that is the most optimal, that is the largest possible number that can be formed with those digits, and in that case also we should return -1. So coming out of the loop we should return -1 if nothing is returned, then the new number that was given to us was already maximum number that can be found from those digits. I hope I have not made any silly mistake. Let's find out. Okay, so there is a error, last digit equals to num modulus 10. What is the problem over here? What is the problem? Okay, over here I can see a problem. Over here I cannot return num directly, I need to convert it into int. I found out basically num should be greater than 0, right, not less than 0. Yes, so it is accepted and bits 100% in all the cases, right? Yeah, that's it guys. It was quite lengthy, but obviously all the things I covered.